Hello everyone. So in this video I'm going to discuss two population models and how to write down the differential equations corresponding to these models. The first one that I'm gonna talk about is unlimited population growth. So in this model the population grows exponentially, so it does not stop, and it assumes that the resources and the space for the population to sustain are unlimited. So the assumption for this model is the rate of growth of the population is proportional to the size of the population. Okay, so if we denote time by t, which is the independent variable, and population, the size of the population, by p, which depends on time, then this assumption can be expressed by this equation. So dp on the left hand side, you can see this is the derivative of population with respect to time t, and from calculus we know that the derivative of a function is the rate of change. So the left hand side is the rate of growth, or the growth rate of the population, and this growth rate is proportional to the size of the population. So p means the size of the population, and k is a constant which is called a proportionality constant. So this constant k depends on what type of species we are looking at. For example, for the rabbit population, k is different, and for bacteria population, k might be different. Okay, so k does not depend on time. So k does not depend on time. So that's why k is called parameter. So in any differential equation, any variable that does not depend on time, we call them parameter. Okay, so for the unlimited population growth, the equation is this one, and if we solve this equation, and in the next video we will discuss the method to solve this equation, but for now just let me write down the final answer, which is population p of t is some constant p0 e to the k times t. This is the population at time t, and you can see that this function grows exponentially. So this model is not realistic because there are limited resources and space, and according to this model these limited resources are ignored. The next model is to make this previous model looks more realistic. So we have to add some assumptions. So there are two assumptions for this model, and this model is called logistic population model. So if the population is small, we need to specify how small this is. The growth rate is proportional to its size, which is like before. Okay, So the rate of growth is proportional to the population size. If the population is too large, so we need to again specify what do we mean by too large, right? The population will decrease exponentially. That means the population growth rate is negative. So growth rate is negative. That means population goes down. Okay. So to specify what this population is small or population is too large, what do they mean? So if we denote by n the maximum population size that environment can handle. Okay, so this is the maximum population size that the resources or environment can sustain. Then the differential equation based on these two assumptions is given by this. Okay, why this is the right differential equation? So let's see. So the first assumption is if the population is small, that means if the population is less than the maximum population size n, then the growth rate is almost exponential. I mean, the population grows almost exponentially, k times p. So growth rate is proportional to the population size. Okay, and which you can see from this equation, if n is when p is small, too small, then p over n is almost 0. Okay, so this guy is 0, p over n is 0. That means dp over dt equals k times p, which is this one. The second assumption, if the population is too large to be supported by the environment, so that means p is bigger than n. Okay, so bigger than n, it's too large. Then what is the growth rate? So you can see if p is bigger than n, then p over n is bigger than 1, right? If you divide both sides by n, you get this guy. So this implies that 1 minus p over n is 0. So this implies that the growth rate is negative, so it decreases. Okay, so two population model, one is unlimited growth model, the another one is logistic population model, which is given by these differential equations. Okay, so that's it in this video. In the next video, we will discuss how to solve these first order equations. Thank you.